Today we'll be learning how to divide monomials. We'll be learning the exponent rules for division. So the essential question is, how do I use the quotient rule to divide monomials? Remember that monomials are just a single term. So we're going to be looking at problems where we're dividing only by a single term. So let's look at what these expressions mean. So I have 2 to the power of 6 divided by 2 to the power of 4. So I'm going to expand these to show what 2 to the power of 6 is. It's 2 multiplied by itself 6 times. So 2 to the power of 4 is 2 multiplied 4 times. When we're dividing, you can look at each individual 2 and see 2 divided by 2 is 1, so that cancels out. So when I'm crossing these out, I want you to think of it as 2 ways. I'm crossing it out, but I'm also kind of writing a 1, a number 1, because something divided by itself is 1. And then when I multiply by 1, it's going to be whatever that other number is. So I have 1 times 1 times 1 times 1 times 2 times 2. So all we're left with at this point is 2 to the power of 2, which is 4. Now, in terms of x, we can expand this as well. X multiplied by itself 8 times divided by x times x times x. And again, x divided by x is 1, because anything divided by itself is 1. So we're left with x to the power of 5. So if you remember the exponent rule for multiplying, when we were multiplying exponents, we added them together. So when we're dividing, we're going to subtract. So the rule is x to the power of m divided by x to the power of n equals x to the power of m minus n. So here's an example. X to the power of 9 divided by x to the power of 5. Instead of expanding it like we did above, we can just write x to the power of 9 minus 5, which is x to the power of 4. We also need to remember that any non-zero term to the power of 0 equals 1. Anything to the power of 0 equals 1. So if we have 73 to the power of 0, that equals 1. Any number to the power of 0 equals 1. Okay, so we have y to the power of 3, or y cubed, divided by y cubed. So we would subtract the exponents, and we end up with y to the power of 0. Well, no matter what y is, any number to the power of 0 is 1. Okay, so let's go to dividing a monomial by a monomial, and then we'll eventually get down to dividing polynomials by monomials. To divide monomials, divide the coefficients. Remember, the coefficient is the big number in front of the variable. Then divide the variables with the same base by subtracting their exponents. So remember, same base means that they have the same letter. They have to be the same variable for you to add or subtract the exponents. Okay, so k to the power of 12 divided by k squared equals k to the power of 12 minus 2, or k to the power of 10. Number 2 has two different variables. We have a and b. So we have a to the power of 6, b to the power of 4, divided by a squared, b to the power of 4. So remember that you can only subtract exponents that have the same base. So I'm going to have a to the power of 6 minus 2, b to the power of 4 minus 4. So that gives me a to the power of 4, b to the power of 0. And I need to simplify that because b to the power of 0 is 1. So I would have 1 times a to the power of 4, or you could just write a to the power of 4, because when 1 is the coefficient, you don't need to write it. Number 3 has a coefficient. So we have 6x to the power of 4 divided by 2x cubed. We're going to divide 6 by 2. So 6 divided by 2, and then subtract the exponents of x. So 6 divided by 2 is 3. And then we have x to the power of 1, or just 3x. We don't typically write 1 as an exponent. It's just invisible most of the time. So if you have to the power of 1, you're just going to write the variable. Number 4, negative 36x to the power of 9, y to the power of 5, divided by 54, x to the power of 3, y squared. Okay, so first we're going to divide the coefficients. So we have negative 36 over 54, subtract the exponents of x, subtract the exponents of y. Now you can use your calculator for negative 36 divided by 54. Just put that in your calculator. It's going to give you a decimal. You're going to hit the button right above the enter that will convert it back to a fraction. So this is essentially simplifying the fraction for you. So you should get in your calculator negative 2/3. And then when we subtract the exponents, we have x to the power of 6, y cubed. Now here we have a trinomial divided by a monomial. The way I want you to treat this as dividing 3 separate things. So rewrite the problem with each individual term being divided by 5. So now we just have 3 separate monomial divided by monomials. So divide the coefficients. 10 divided by 5 is 2. And then we don't have an x on the bottom, so we don't need to change the exponents. So we just keep x squared. Now we have 5x divided by 5. 5 divided by 5 is 1. Remember, we're not going to write 1 as a coefficient, so we'll just leave that as x. Negative 15 divided by 5 is negative 3. So my answer is 2x squared plus x minus 3. Here we have a binomial divided by a monomial. Rewrite it with each term being divided by 5x. Okay, negative 20 divided by 5 is negative 4. Remember, there's an invisible 1 here. So we need to subtract the exponents. 2 minus 1 is 1. And we don't need to write the exponent there, because we don't write the 1. Now we have 5x divided by 5x. Now 5 divided by 5 is 1, and x divided by x is 1. So both of those terms cancel out. We don't have 0 though, because they are 1s. 1 times 1 is 1. So we're going to make sure we write the 1 there. So if you have a term divided by this by itself, remember that it's 1, it's not 0. Okay, another trinomial. Okay, starting with the first one, 16 divided by 4 is 4. 6 minus 2 is 4. Negative 12 divided by 4 is negative 3. And 4 minus 2 is 2. And this last term, again, it's the full term divided by this by itself. So that cancels out. We end up with y to the power of 0, which is also 1. So we're just going to write plus 1. And the last example is a binomial divided by a trinomial, or divided by a monomial. However, we do have 2 variables in here. So remember that you can only subtract the exponents of variables that are the same. So I'm going to write this out. Okay, negative 14 divided by 7 is negative 2. For x, we have 12 minus 2, which is 10. And then for y squared, we have 2 minus 2, which is 0. So this becomes 1, or you just don't write it, because negative 2x to the power of 10 times 1 would just be negative 2x to the power of 10. Now we have 7 divided by 7, which cancels out, x squared divided by x squared, y squared divided by y squared. So again, we just write 1. So you don't need the 1 if there are other variables or coefficients in the term, but you do need to write the 1 if there's nothing left. So that's what you'll be doing on today's practice.